good news. So you will have to use. So the comparison between conducted dengan radiated is conducted ni we are using travel through power line famous line artist conductor, which is for example using the coaxial cable using the electric into the oscilloscope and other oscilloscope. So measure using hand touching the flat plate antennas. So we need to have the flat plate and the wave will be adhered to the oscilloscope and can interfere with other device connected to the same power line or signal path. So the wave will be adhered to the other oscilloscope because we connect the coaxial cable between this oscilloscope and other oscilloscope. So for the radiated emission is probably through free space, which is for example the air we using the spark plug and the wave will be adhered to this oscilloscope and other oscilloscope. So
do you have that figures schematic? Can you show me?
This for
the schematic, the thing that you explained to me right now. Do you have that figure?
So second measure without touching the flat plate antennas. So the spark plug will be we push the spark plug and the wave will be adhered and can interfere with nearby wireless communication device or safety equipment. So this oscilloscope and other oscilloscope is depend between the range between the flat plate that we the flat plate and the other device. So this is the result of the conductor emission. So we need to take
Find first to any of them. Oh, you have already. Okay.
So for this result, we need to take 5%. So for the movie, we set the volt per division is 100 millivolt, and time per division we set 100 millisecond. So for the rising time, we measure between 2 points, which is 90% to the 10%. So we measure between 90% and 10%, then we get 0.8 millisecond. And the overall path duration, which is we take 2 points between 10% and also 90%. So that duration between time we have 4.8 millisecond. The highest amplitude, which is 0.208 volt, and zero crossing time we measure between that one waveform we measure 2 point that cross the zero to sketch. This is for rising time. Between this and this, 10% and 90%. For the path duration, we set 10% and 9% of it. So we take this time. So this is for path duration. And the highest amplitude, we take the highest that we have overshoot, we take here. So we take here for the highest amplitude. And the zero crossing time, we measure into this point until this point. So that's the what we call zero crossing time. And the half full width, we divide the the highest amplitude. So we get 0.104. So after we done this, we repeating the same with others that hand. She is 5 students.
How do you select from all there? You have seen so many buses, so many buses, 3 or 4, so many buses. So then how do you decide it? How do you decide to select the features that you will analyze?
So basically, from this data,
No, again, my question. You see, you have so many pulses, right? Then you have to decide which one is suitable, right? So then you have to analyze, like what Shamil explained just now. So how you see, this is, I mean, for this particular case, you're unable to analyze. Because why? Because this is in JPEG format. So how do you analyze?
We use the MATLAB.
yes.
So where is the result? In MATLAB? So by right, we should have that in your
Oh, in slide.
report, in the slide.
Oh.
So this one. So we take from the first one. So we take the highest. So we do for the same method for the two area also adi. So basically we have to use the most nice signal. So that's why we are
Cakap ada letak dalam
this for the radiated emission result. So this one is the emission result. So radiated emission result basically is a pass through air with electromagnetic wave. So basically we are set. So
There's something wrong with your result. By right, if you go to 30 centimeter, you shouldn't get 1.6 because the higher the distance, the lower will be amplitude. So there's something wrong.
Oh.
You have to check. You have to double check. This is not right. Yeah. Okay.
so for this 30 cm.
Oh yeah. I do not know how this things happen. By right, the first one, the 15 centimeter should be the highest.
Oh.
Yeah. So there's something wrong with the result. Yeah. Please double check. Yeah.
Oh.
Okay. Yeah.
So that as the champion mentioned,
Okay.
so we got so 500, the positive, get back to the negative signal. 0 point, so we got the 1, so we also do the same thing.
How do you identify overall pulse duration? Let's have a look at one. Okay, so how do you identify overall pulse duration? Individual pulse. Because millisecond is considered big duration. But for individual pulse, the things that you explain to me right now is about individual pulse. Only one, right? Only one pulse, right? To me, it's about, I know, something wrong. Or is it the duration that you have taken from the first event until the end of the event? Which one? No. Only one part.
Only one.
Double check. Are you sure it's millisecond? Are you sure it should be around that range or micro? Remember last time?
Yeah. That's why I get a milli.
Double check. Double check. For what case? No, I mean for what case? For what case? We have to miss so leveling must be very strong. No, I mean leveling for the case. Or different of before the case
Maybe from this
Again, guys, remember what is the meaning of conclusion? The meaning of conclusion is about it must be based on your result. So therefore, you have to make conclusion based on your own findings. So that is the smart way, the perfect way. It is not about something that you explain based on theoretical part or whatsoever. It must based on your based on your pure result, based on your observation. Like for instance, based on your figure, so you make conclusion based on that. What is the finding? Basically you have done. You have done. So you make in the form of, you can ask ChatGPT, this is the figure. Can you describe? Use the facilities. You just map and then ask ChatGPT to explain. Can you help me to make a conclusion based on this result? Okay. What is the weakness? Why I don't give you highest mark? Why? Because basically you can explain, but your explanation is not based on methodology. It's now okay, I mean you're sure something can, but in those slides, please prepare, so clearly, this is the proceed, so you based on this, but okay, then you should please show, okay, this one, by right, we should make a cover up picture, zoom, cover up picture lah. Basically you must, that's why I ask you again, just now, figure. Okay, let's talk about that. So you enlarge for the case of individual parts for that particular analysis result, right? That one. So you should really show this is here and here and zero crossing. So make it clearly. So it's not like this, right? So how will you? Okay. Now before amplify, could you please show me? The procedure for conductor case. How do you measure conductor case? Yeah, sure. No, you don't have to connect. Just show me how do you set your. First of all, what you should do?
Somehow you need to set the trigger.
Before that, there must be something like.
First you need to connect the flat antenna.
I mean, just don't focus on the antenna. Just focus on this part. So what you should do? Okay.
First of all, turn on, and then you need to put the
Before you, okay, after you switch on, and before you press trigger menu, you must do something with the channel setting, right? What you should do? Press which one? Then what you should do next? Could you please press? Okay, next what you should do?
The voltage per division to be adjust.
And what else?
Time per division.
What you should, okay, tapi how you make the decision? DC. Why DC? Why not AC? Why AC?
Because it has positive and negative side.
Yes, because it fluctuates. Your signal is about something related to radiation.
Yes.
It's changed rapidly. Then you have to have that particular setting. And then what else? What about W limit?
Yes. Then we limit. We set to 50.
Just let it be. Because that is the behavior of the oscilloscope. Okay, next.
We trigger.
Set the trigger setting.
Go through one by one. All this.
Volt per division.
Now we say. And then what about probe?
Probe we need to
Why? Then why?
Because we need to get the exact
Ratio. One end to another end is about one. What about invert? Just let it be. Yes. Then you have to press. So please do that clearly in presentation slide.
Oh.
Because you didn't show me.
Oh, the procedure.
So I have to hold that part.
Okay.
Yeah, I can't give you that marks. Yeah, if you don't make it clearly, then you should deserve to get 0 lah. Yeah. So anyhow, this is the word. So I hold this part lah. Yeah. P4 and P5. Yeah. Later on, I'll come back.
Thank you, sir.
Thank you, sir.
Next.